morning, children. Welcome to Elemental Chem Talks. Yeah, I'm Jagdish. Today, I'm going to discuss about resonating structures. This is well-known, very important question repeatedly asking in mains as well as NEET. So here they will give you different structures. So we need to find the stability. So here I'm going to tell you some rules to decide the stability of resonating structures. So we need to follow the sequence. In that, the first one the first one is neutral neutral structures are more stable than charged structures, right? Neutral structures are more stable than charged structures. Now let me give one example. Here I'm taking carboxylic acid, RCOOH. Now if you write its resonating structure, so this is how electron shifts takes place. R C O minus, double bond O plus and H. Now this is a structure 1 and structure 2. So here according to the first rule, in structure 1 there are no charges, structure 2 we have some charges. So we can conclude that the first structure is more stable than second structure, right? I hope you understood, right? I repeat, neutral resonating structures, or you can say neutral structures, are more stable than the charged one. Got it? Yes. Next, the second one. After, if both are charged structures, then we should go with the second rule. So based on that, we can find out stability. So the second rule is stability of resonating structure is directly proportional to number of pi bonds in the respective structure. Okay. If pi bonds are more, then stability will be more, right? So here I'm going to give you some structures here. So you should tell me which is more stable, right? You should tell me which is more stable. So CH2 plus double bond OCH3, and another structure is, yes, CH2 double bond here plus charge OCH3, and the third structure is, it looks like this one, CH2 double bond here double bond O plus CH3, and another one is, it looks like this, okay, double bond CH2 double bond here plus charge O CH3. Now all the four structures are charged. Once they are charged, so we should decide the stability based on the pi bonds. I told you here in the first structure we have 3 pi bonds, second structure we have 3 pi bonds, and third structure we have 4 pi bonds, and last structure we have 3 pi bonds. So once we calculate pi bonds, so it's directly proportional stability. Now tell me which is more stable here. Yes, here the third structure is more stable because it is having more number of pi bonds. This is the second rule, right? Then let's see the third one. Here in the third rule, it's stating that if any resonating structure, if it is containing a negative charge on electronegative atom, positive charge on electropositive atom, those resonating structures are stable. Got it? Now let me give you one example. Here I'm taking resonating structures of phenoxide. Okay, so this is phenoxide ion, and I'm writing another resonating structure, double bond O minus double bond. Yes. Now here, if you see these two, which will be more stable? Yes. Now, as per the second rule, it is having 3 pi bonds. As per, here we have 3 pi bonds. Now, when pi bonds are same, we need to decide the stability based on the third rule. So here, oxygen is an electronegative atom. It is carrying negative charge. Here, carbon is the electronegative atom. It's carrying negative charge. So that first structure is more stable than the second one. Right? I hope you got it. Right. Next, see, fourth rule, charge separation means if any resonating structure, if the distance between the charges, if it is less, then it is more stable. If the distance between the charges, if the distance is more, then it is less stable. then it is less stable, right? Now let me give you one example here, right? Let's see resonating structures of aniline. In those structures, I selected two. One is, it looks like this, NH2 plus, double bond, here negative charge. And another resonating structure I selected was this one, double bond, NH2 plus, right? Double bond, negative. Now see, both are charged, both are having 3 pi bonds, okay? And nitrogen, it's electronegative. In both the case, it is having positive charge. In both the case, it is having positive charge. So now stability is decided by the distance. Stability is decided by the distance, right? Now here, nitrogen, carbon, carbon. So here, distance 1, 2, 3. 1 comma 3 positions. Here 1, 2, 3, 4, 5. 1 and 4, 5 positions. So here we have less charge separation. Less charge separation, so that it is, this structure is more stable, right, than the second structure. I hope you got it, right? Right. And another one, we have another rule, that is, see, very, very important. Resonating structures are least stable. Means if you want to identify the least stable resonating structure, one of the way is the adjacent atoms, they should have similar charges. Adjacent atoms, they should have similar charges, right? So one of the example here, you can write like this. Similar charges means adjacent atoms, they should not have plus plus charge, they should not have minus minus charge, they should not have minus and lone pair, okay? Even this is also leads to less stability, right? So I'll give you one example now. See, very important. Now here CH2 double bond CH, single bond CH plus, single bond CH minus, and NH2. Let's say this is one of the structure, okay? And the second resonating structure is CH2 minus, single bond CH plus, single bond CH, double bond CH, single bond NH2. Now students, can you tell me out of these two which is least stable? Which is least stable? Yes, whatever you are thinking, that's absolutely correct. So here, the first one is less stable. The first one is less stable. Why it is less stable? Because carbon, it is having negative charge. The adjacent atom nitrogen, it is having lone pair. It is having lone pair. So similar charges, adjacent atoms, if they have, then the structure leads to less stability, right? I hope you understood, ma? So you need to follow all the 5 rules in the sequence. So you need to compare rule by rule, so that you can find out stability order, you can find out most stable and least stable, right? Most and least you can find out by using these 5 rules, right? Thank you, ma.